Hello students, as in this lecture we're gonna start with a new topic, that is definite integration. As I told you all that without knowing the integration chapter, this chapter it will become very difficult to understand, as uh, I can say this is the extended part of the integration chapter. And in this chapter there are hardly 2-3 exercises are there, but 70 to 80% of the sum it is based on the integration. Okay, so if you are perfect with integration chapter, I bet you uh, out of 2-3 exercise, the two exercise it is very easy, and one exercise actually it is based on the definite integration formula. It's based on the property of that particular chapter. Okay, but remaining 70 to 80% of the sums actually it is based on the integration chapter only. So if you are perfect with all the types, all the methods, okay, if you are well known that the particular question it is from so and so exercise, then definitely the chapter will gonna become very easy, as in the exercise the sums will be mixed up, and you have to guess that for the particular question which method we have to apply that particular question, by which property, by which method, by which type we have to solve, as it will not mention. Suppose question is there, it will not mention that the particular question it is from the integration chapter of exercise number so and so, or else it is a type number 1 or type number 2, like that. As I had explained the integration chapter whole and soul in type wise, so it is on you if you want to remember the sums as type wise or exercise wise. Okay, it will be better if you remember the sums as type wise. Okay, so here the sums will be mixed, so you have to guess that for the particular question which property we have to use. As I told that 70 to 80% of the sums it is based on the integration. If you are perfect with all the types, okay, all the types, all the concept, so definitely out of three exercise two will be very easy, and the one exercise it is based on the actual definite integration properties. Okay, so there the last exercise it is based on the properties, I can say. Okay, so now I hope you all might be knowing all the formulas, all the basic formulas, all the um, types. Just simply you have to guess. The very important thing here is what? The guessing. Like the first question, if you have to guess it is from which exercise or from which type, or by uh, or that particular question we have to solve by which property. So if you know that thing, then definitely the chapter will be easy for you all. Okay, so it's all depend on the integration. If your integration is perfect, yes, this chapter is easy. So let's begin with the concept. We'll see what is the difference between the definite integration and integration. One simple difference I will say, in integration we used to write plus c. Here no need of writing plus c. There is no need to consider c. Okay. However, the constant of the integration get eliminated here. In this chapter, there is no need of writing or to consider c, because any of the constant of the integration it will get eliminated. Here, what was c? C it was the integration constant, which we used to say what c is called as constant of integration, and it takes any value, hence is also known as arbitrary constant. Such an integral is called as indefinite integration, as c can take any value, hence it is called as what? Arbitrary constant. And such types of an integral is called as indefinite integral. So here c is what? Integration, integral constant we can say. And here no need of writing c, no need to consider c here, because anyhow the value of c will get eliminated here. So now I will explain, I will show by using one example also why we there is no why there is no need of writing this c. Okay, so just simple distinguish is what I can say here. We used to write plus c here. In definite integration, no need of writing plus c. Okay, now, and definite integral is what? And now how to guess that particular question is from the integration or definite integral? It is very simple, by this value. Okay, so what is this a to b? These are the these are a and b are called as limits of integration. These are called as limits of integration, where a is called as lower limit of integral and b is called as upper limit. So this is lower limit and this is what? Upper limit. Okay, it is very simple. Whenever you have this value, so that means the sums are from the definite integration. If you, okay, got the point? Without value, it is from the integration chapter. And see to it that in integration chapter we write plus c. Here no need of writing plus c, so because here the constant of integration will get eliminated. Okay, so here c can take any value, so such types of integral actually is known as what? Indefined. So that's why the chapter name is indefined, because here c is not defined properly. Here of course the c will get cancelled, there is no need of writing c, so that means I can say that it is defined. C will get eliminated here, yes or no? So that's the difference here. So remember just one thing, that in this chapter there is no need to consider c. Why? I will explain now. As we know that, suppose integration of f of x, here some function is there. If you are getting answer as g of x, as we are integrating with respect to x, so g of x plus c. Plus c is known as integral constant, yes or no? Okay, now here why there is no need to consider c? Listen here, as this is what the two values which we can say. Actually in this chapter it is known as what? Limits of integration, where a stand for this bottom number stand for lower limit, and this is known as what? Upper limit. I hope you all might be knowing some basic things about this, because this types of integral basically we use in physics to find the derivation part. Okay, and I hope you all might be knowing that this is called as what? Lower limit, and this is called as what? Upper limit, and how to tackle the sums with this limit, yes or no? Okay, for common section they don't know about this, what is the meaning of a and b. Okay, but for science they might be knowing, uh, where a is known as what? Lower limit, and b is known as what? Upper limit. Okay, basically this small thing which you had used, you had applied in 11th physics as well as in 12th physics also, to derivate the concept, to derivate the formulas, yes or no? And simply here you all might be knowing, you have to substitute the upper limit and then lower limit. Okay, upper limit minus lower limit. Now listen here, I will show now why there is no need to consider c, and how the constant of integration will get eliminated here. Okay, as we know that f of x, here we got g of x plus c. F of x, of course here also, after integrating with respect to x, here also we'll get a gx plus c. But here we have the limits of the integration. So now what to do about this? Okay, in the next step, after integrating with respect to x, as I told that 70 of 80% of the sum, it is based on the integration, yes or no? And the 70 to 80%, I will say not 80, also 90 to 99% of the sums, the method, the format will be based on the integration only. The last 1% will be what? The definite integral. So now what is definite integral? Now we'll see. Simply after integrating with respect to x, simply what you have to do, you have to substitute, you have to replace the value of x simply by the upper limit and the lower limit. Okay, now suppose we know that f of x answer is g of x plus c. Okay, integration a to b, we can read this as a to b. Okay, or you can say this is lower limit and this is upper limit. So we know that integrating with respect to x to this function, you will get what? G of x plus c. Of course integration will get removed, but a to b you will write here b and a, upper limit and lower limit. After this what you will do, simply you will replace the value of x first by b then by a. For always you have to put upper limit first and then lower limit. Okay, so your upper limit minus lower limit you have to do, then only the c will get eliminated. Okay, don't write plus. If you write plus, of course the c will be there. Okay, so upper limit minus lower limit is the concept. So simply what you have to do, okay, after integrating with respect to x, simply you have to replace the value of x by first by b. Okay, then after that first you will put the upper limit and then the lower limit. Got the point? That's it. You have to do the integration with respect to x. After that that is what last part is what, simply you have to replace the value of x by first by upper limit and then by lower limit. Just simply bracket open, so here you will get g of b plus c minus g of a minus plus minus. Yes or no? So here clearly we can see that here plus and c plus c minus c will get cancelled, and here we left with g of b minus g of a. I hope you all understood how here in this chapter the c get eliminated, as there is no need to consider c, no need to write the constant of integration in this chapter. However, when you will substitute the upper limit and the lower limit, anyhow for each and every sum the c will get cancelled. Okay, so remember this thing, whenever you will integrate with respect to x, no need of writing c. If you write c also after replacing the value of x by upper limit and lower limit, at the end what will be the conclusion? That the constant of integration will get eliminated, and there is no need of writing or need to consider c. Okay, so that is a small concept and small difference between the indefinite and definite. Here we write plus c, as c is not defined here. C can take any place, any values. Okay, understood? And here anyhow after replacing the value of upper limit and lower limit, c will get cancelled. Okay, so I hope you all understood the difference between the integration, indefinite integral and definite integral. So let's take some few examples. Okay, as the few example which we will be going to see, as of course it will be based on the integration chapter, and if you are perfect with integration chapter, so definitely this chapter will be very easy for you all. Okay, just simply you have to guess that particular question, it is from which exercise or from which type, or for that particular question which property, which formula we have to apply. That's it, and rest part will be what, just simply you have to replace the value of upper limit and then lower limit, you will get the answer. Okay, got the point? Understood? At the end what you will see, the final answer, it will be without x. Without x, the final answer, it will be without x. Okay, because here a and b will be what, numbers, finite numbers. Actually a and b, it is known as what, finite numbers. Remember this. Okay, so these are the we can see the domain of x. These are the domain of x. Okay, domain of x to a to b. Yes or no? So chalo, so now we'll take some few example. As here we have first one. Now just forget about this part. Don't think that 2 and 0 it is there for this question. Okay, so what is integration of x square? Can I say this x square, it look like x raised to n? Yes or no? So what is x raised to n? What is x raised to n? We know that it is x raised to n plus 1 upon n plus 1 plus c. Yes or no? Yes or no? Okay, but here we know that for definite integration, you have no need of writing c, as anyhow there is anyhow the constant of integration will get eliminated. Just now only I had explained how it will get eliminated after replacing the value of upper limit and the lower limit. So if you want you can write, or else there is no use only to mention that c, anyhow it will get at second last step it will get cancelled. Okay, so now, so we'll apply the formula, we'll keep this integral. Okay, as here we have this question, so now we'll start. We got the idea. We come to know that for this question we have to use this formula. That only I had explained just now. Without knowing the integration chapter it will be very difficult to understand this chapter. Okay, just simply you have to guess that particular question, for that particular question which properties and which method we have to apply. As here for the first sum we got the idea, it is a basic integral formula, as it look like x raised to n. What is x raised to n? X raised to n plus 1 upon n plus 1 plus c. Okay, so now, so here integrating with respect to x, so here you will get x raised to n plus 1 upon n plus 1. Okay, here no need of writing plus c. Okay, 2 and 0 will come. Okay, now after this x raised to 3 upon 3 upper limit and then lower limit. Okay, so now simply what you have to do, just now only I had explained, first you will replace the value of x by what? 2. Okay, x, replace the value of x by 2 first. This 3 will be same as it is, then you will write minus, and then after that you have to replace the value of x by 0, as this 0 indicate what? It is the lower limit and this is the upper limit. So first you have to put the upper limit and then the lower limit. Okay, then here in the next step you will get what? 2 cube, it is what? 8 upon 3 minus 0 cube is 0, so 0 upon any number will be what? 0 here. So here we got the final answer, it is 8 upon 3, and 8 upon 3 we cannot cancel the number further. Okay, so this is the answer for this integral with the limit up, lower limit as 0 and the upper limit as 2. If you write plus c here, so what will happen? Anyhow in the second last step the c will get cancelled, as here I had explained how it will get cancelled. Yes or no? So remember this, for definite integral there is no need to consider c, as anyhow the constant of the integration gets eliminated. Okay, got the point? Understood? Simply you have to guess that particular question we have to solve, we have to apply which property, which method, we have to solve that sum by using which concept. That's it. And rest, simply you have to replace the value of x by first by upper limit, then write minus in between, and then lower limit. If you write minus only, then only the constant of integration will get eliminated. Understood? Okay, so now let's take one more example. As here we have I equals to integral 0 to pi by 2. Okay, so I equal to, will integrate this part. So integration of cos, so we know that integration of cos is what? Sin x plus c. So here no need of writing plus c, so we'll write directly cos, integration of cos with respect to x is what? Sin x. Here we'll write upper limit, lower limit. Okay, I equals to, first you have to replace the value of x by pi by 2, then by 0. Okay, so sin pi by 2 means what? 90. Sin 0 is what? 0. So 1 minus 0 is what? 1. So here we got the answer. That's it. Simply guess for that particular question which formula, which property we have to apply. You have to guess that particular question, it is from which exercise. So that is very important thing. Okay, or else it is from which type, whether it is type number 1, type number 2. Okay, and then integrate with respect to x, and then simply you have to replace the value of x first by upper limit, then by lower limit. You will get the answer. Okay, so let's check one more basic example. As here we have I equals to 4 to 9 1 upon root x. Can I write this 1 upon root x as x raised to 1 by 2? Yes or no? As here we don't have any ready-made integral for 1 upon root x into dx. Yes or no? As integration of x raised to n, we know that. For even for the cos x, integration of cos x, we know. As in the integration chapter, we don't have the ready-made formula for this. Okay, so here for this sum we'll do little adjustment, and then we'll check by which property or by which formula we have to solve or tackle this sum. So first step, we know that root x, it can be written as x raised to 1 by 2. Okay, further this 1 upon x raised to 1 by 2, can I write this as x raised to minus 1 by 2? Yes or no? Got the point? Understood? Now clearly we can see that this look like what? Integration of x raised to n formula. Yes or no? What is x raised to n formula? X raised to n plus 1 upon n plus 1 plus c. Yes or no? Whether the value of n it is positive, negative, or it is in fraction, doesn't matter, but it look like what? X raised to n. As here n can have any value, it can be positive, it can be negative also, it can be in fraction also. So we got the idea that for this question we have to apply the x raised to n formula. But in the initial step we did a little adjustment to convert this unknown integral thing to known integral. As here we don't have the ready-made integration formula for 1 upon root x, so I had converted this whole thing into a known integral formula, that is x raised to n, which we can write as x raised to n plus 1 upon n plus 1 plus c. Okay, so apply the formula, so you will get x raised to, oh okay, so we'll write the same step again. You cancel this step. Okay, I equals to integrate, so here you will get what? X raised to n plus 1 upon n plus 1, no need of writing plus c, then here 9 and 4 will come. Okay, then as clearly we can see that when you will solve this part, minus 1 by 2 plus 1, cross it, so here 2 minus, so this will be 1 by 2, and here cross it, so you will get again 1 by 2, 9 by 4. Okay, now let's see how to find the answer. So here can I write this as 1 by 2, it will go up, it will be what? 2. Yes or no? And x raised to 1 by 2, again we can write as what? Root x. Yes or no? 9 and 4. Got the point? Understood? Okay, so first you will write what? You will replace the value of x by 9, then you will put minus, then x by 4. Yes or no? And we know that root 9 is what? 3. Your root 4 is what? 2. So 2 3 side is 6. 2 2 side is 4. 6 minus 4, that is what? 2. So here we got the answer for this integral 4 to 9. 1 upon root x is what? 2 by. Okay, it is only 2, not 2 by. Okay, so in this way you have to present your sum. Okay, simply you have to guess. Without guessing you cannot able to find your answer, as it is very important to guess the type, the method, the particular question it is from which exercise. As in the exercise it will be not mentioned anywhere that this sum it is from so and so exercise, it is from so and so type. Okay, it is from the exercise number 1.4, that is question number 1. No, nothing. there will be a mixture of sum. You have to guess for the first question which property will come, for the second question which property, which concept, or by which type we have to tackle the sum. Okay, so that is very important. The guessing part is very important, and rest, it is very simple. As I told, 70 to 80% of the sum, it is based on the integration. Okay, just simply you have to integrate with respect to x by guessing a suitable type or a suitable formulas. As here we saw the first example, it was in the form of x raised to n. We got the idea. I had guessed the first sum properly as it looked like x raised to n. Apply the formula, and simply in definite integral what you have to do, replace the value of x first by upper limit, then lower limit. Here no need of writing c. If you write c also, here I had explained how it will get eliminated, yes or no. So there is no need of writing or to consider c in definite integration. Okay, so as you took three examples, okay, so let's move on some few more example, then you will come to know that how to guess, how to apply, and how to frame your steps. Okay, okay, so let's take this example. As here we have I equals to 1 to 9. 1 is a lower limit and 9 is what, upper limit, x plus 1 root x. And just simply you have to guess that particular question, it is from which exercise or from which type. As clearly we can see that this look like what, u by v. And integration, we know that we have property based on addition, subtraction, and multiplication. Okay, whenever the sum it is based on integral u by v, so a little adjustment you have to do in a such a way that you have to remove this u by v format. As clearly we can see that in the denominator here we have only one term, yes or no. So here in the first step, can I write this root x as x raised to 1 by 2? Okay, now as here denominator is single term, so we can separate the denominator, yes or no. So here you will get what, x upon x raised to 1 upon 2 plus 1 upon x raised to 1 by 2 into dx, yes or no. So I equals to integral 1 upon 9. Here nothing is there, so we can write as 1. As this look like what, a raised to m divided by a raised to n. So a raised to m minus n. So this can be written as x raised to 1 minus 1 by 2. So here you will get what, x raised to 1 by 2 as the answer. Okay, so here after solving this part by using basic indices formula, so here you will get x raised to 1 by 2 plus 1 upon x raised to 1 by 2. Just now only we saw this step can be written as what, x raised to minus 1 by 2. So this can be written as x raised to minus 1 by 2 into dx. As in the bracket here we have two term and it is connected with the plus symbol. As just now only I told, you have to adjust the sum in a such a way that you have to remove this u by v format. Okay, just by doing some simplest algebraical step or by using some, there are many types in integration we saw. Majority of the sum it is in the form of u by v only. Okay, so this was the basic sum. Actually here no need of using any type, any concept. Okay, just simply check, here we have only single term, so we can separate the denominator. Okay, here till here we got the answer. I hope you all understood this step. As here we have two term, so we can separate the integration also, yes or no. X raised to 1 by 2 into dx plus integral x raised to minus 1 by 2 into dx. Now we'll integrate with respect to x. As this look like what, it look like x raised to n formula. So what is x raised to n? X raised to n plus 1 upon n plus 1 plus c, yes or no. So here we'll write what, x raised to n plus 1 upon n plus 1. You have no need of writing c, yes or no, plus here also will apply the formula, so x raised to minus 1 by 2 plus 1 n plus 1 n plus 1, yes or no. Then further this we can write as what, x raised to, cross it, so here you will get 3 by 2 upon 3 by 2, yes or no. Here you will get what, x raised to 1 by 2 upon 1 by 2. Okay, so now after this, can I write this x raised to 1 by 2 as root x? Okay, and x raised to 3 by 2, can I write this as x raised to 1 by 2 like this? And x raised to 1 by 2 is what, root x. Got the point? Okay, so this step I can write as what, root x the whole cube upon 3 by 2, yes or no. X raised to 1 by 2 we can write as what, root x. I hope you understood this step what I did here, yes or no. Now after this we have to replace the value of x. Okay, first we'll shift, we'll bring this 2 up, so this will be what, 2 root x the whole cube upon 3 plus 2 root x 9 and 1, yes or no. So first you will replace the value of x by 9, yes or no, then minus x by 1. Here also same, first by 9 you will put the lower limit and then the upper limit. Okay, so 2 upon 3, 9 square root of 9 is what, 3. 3 cube is what, 27. 2 upon 3, square root of 1 is 1. 1 cube is what, 1. Square root of 9 is what, 3, yes or no. Square root of 1 is what, 1. So further this we can write as what, 3 ones are 3 nines are, yes or no. Okay, so 2 nines are, it is what, 18, minus 2 by 3 plus 2 threes are 6 minus 2, yes or no. So this can be written as what, 54 minus 2 upon 3 plus 6 minus 2 is what, 4. Okay, 54 minus 2 is 52 upon 3 plus 4. As further we cannot cancel this number 52 and 3. Okay, so cross it, so this will be what, 52 plus 12 upon 3, so this is 64 by 3. That's the answer. Here also we cannot cancel the number. I hope you understood how to present the sum, yes or no. So here just I took some basic examples based on x raised to n, based on basic integral formulas, yes or no. I hope you all understood the concept, the difference between the definite integration as well as integration. And remember one thing, how to guess the particular question, it is from definite or integration, the indefinite integral. It is very simple, by seeing this value, if you have the limits, integral limits, so the sums are from the definite integral. Without limit, it is from indefinite integral. And see to that In this chapter you have no need of writing C. Here I had explained why so. Anyhow, there is no need of writing C. The C will get eliminated. Yes or no? So just I took a basic example to explain and to clear what is exact meaning and exact definition of definite integral, and how to use and how to find the answer with using the value of limits. Okay, so in the next lecture we're gonna start with the types. Types means what? You have to guess that particular question it is from which type, guess, apply the suitable formula with respect to the integration, and then after that just simply you have to replace the value of x by lower limit and then upper limit. You will get the answer. Okay, so the remaining part we'll see in the next lecture. Till then, goodbye.